This video tutorial covers calculations relating mass of 1 mole to total mass and number of moles. The three sorts of question which we're going to cover are the questions such as what is the mass in grams of 4 moles of sulfur trioxide? How many moles of sodium hydroxide are there in 8 grams of sodium hydroxide? And finally, what is the mass of 1 mole of a compound given 10 grams contains 0.1 moles of this compound? So the first question type, what is the mass in grams of 4 moles of sulfur trioxide? Well, the first thing we need to work out is what is the mass of 1 mole of sulfur trioxide? Well, if we look at the formula, it consists of 1 mole of sulfur and 3 moles of oxygen atoms. We can find out the mass of 1 mole of sulfur atoms and also the mass of 1 mole of oxygen atoms from our periodic table. So 1 mole of sulfur will have a mass of 32 grams and 1 mole of oxygen atoms will have a mass of 16 grams. If we do our calculation, we can find out the mass of 1 mole of sulfur trioxide is 80 grams. If we have 1 mole having a mass of 80 grams, what will the mass of 4 moles be? So we can do the calculation and find out the mass of 1 mole of sulfur trioxide will be 320 grams. We can also think here, we've also got the key equation here. The total mass of substance is equal to the mass of 1 mole multiplied by the number of moles. I would suggest you write this equation down. Total mass of moles is equal to the number of moles multiplied by the mass of 1 mole. We're going to move on to another question which is exactly the same effectively, and I would like you to have a go at practicing with. What is the mass in grams of 0.4 moles of sodium hydroxide? If you haven't got a periodic table, I shall show you the relative atomic masses for sodium, oxygen and hydrogen. Okay, hopefully you've had a go at solving this question, and we will now go through the question. Firstly, we need to work out the mass of 1 mole of sodium hydroxide. But before that, we should obviously write down our key equation. Total mass of moles is equal to the number of moles multiplied by the mass of 1 mole. Stage 1. Mass of 1 mole of sodium hydroxide. If we look at the formula, we can see it consists of 1 mole of sodium, 1 mole of oxygen and 1 mole of hydrogen atoms. So the mass of 1 mole of sodium hydroxide is equal to 40 grams. The mass of 0.4 moles of sodium hydroxide is going to be equal to the number of moles multiplied by the mass of 1 mole. So 40 grams for 1 mole multiplied by 0.4, giving us a total mass of 16 grams. The final example of this question type is what is the mass in grams of 0.5 moles of magnesium hydroxide? Try solving this question for yourself and then go through this example. Stage 1. Write down our key equation. Stage 2. Work out the mass of 1 mole of magnesium hydroxide. Obviously take care when you're working out the mass of 1 mole of magnesium hydroxide to make sure you multiplied by 2 the mass of 1 mole of oxygen atoms and also the mass of 1 mole of hydrogen atoms. I sometimes find it easier to do, if I've got the correct sort of calculator, 24 plus open brackets, 16 plus 1 close brackets times 2, rather than doing it like I've done it here. Next stage, we've got 0.5 moles, so it's going to be 58 times by 0.5, giving us a total mass of 29 grams. If you're not very familiar or confident with rearranging equations, we're going to go and have a look at magic triangles. So using our key equation, total mass of moles is equal to number of moles multiplied by the mass of 1 mole. We're going to put this into a magic triangle. Stage 1, we draw a triangle. we draw some lines on the triangle like this. The item in the equation which is on its own goes in the top, and the two things which are multiplied together go here and here. To use the magic triangle, you need to find out what you want to calculate. What you do then is you cover what you want to calculate with your finger, and then you have the equation which you need. So, for example, if you want the total mass of moles, it will be equal to the number of moles multiplied by the mass of 1 mole. If you wish to calculate the number of moles is equal to the total mass of moles divided by the mass of 1 mole. And finally, if you wish to calculate the mass of 1 mole, you cover that with your finger and you will see it's equal to total mass of moles divided by number of moles. So you might wish to copy down this magic triangle if you're not very happy rearranging or using the equation which is shown at the top of the screen. We move on to a different type of question now. How many moles of sodium hydroxide are there in 8 grams of sodium hydroxide? The same as last time, we write down our equation. From our equation, we can see what we know and what we don't know. We do know the total mass of moles, which is 8 grams. We can also calculate the mass of 1 mole. And what the question is asking is, what is the number of moles of sodium hydroxide present? So starting off with working out the mass of 1 mole of sodium hydroxide, we can find the mass of 1 mole of sodium hydroxide is 40 grams. We can now rearrange the equation to say that the number of moles is equal to the total mass of moles divided by the mass of 1 mole. To achieve this, I've divided both sides of the equation by the mass of 1 mole. And obviously, if we have mass of 1 mole divided by the mass of 1 mole, it cancels out to give us 1. We now plug the values into our equation here. So 8 grams divided by 40, giving us a total mass of 0.2 moles. Here's a question which is remarkably similar to the last one, apart from we have a different substance here. Here it is magnesium hydroxide, and it's asking how many moles of magnesium hydroxide are present in 5.8 grams. So it's exactly the same strategy as last time. Have a go at the question and then restart the video to see if you've got it correct. Using our periodic table, we can work out the mass of 1 mole of magnesium hydroxide. But to follow the sequence precisely, we obviously need to write down our equation, work out what we know, what we don't know, and solve it. So the mass of 1 mole of magnesium hydroxide can be calculated as follows. Note this time round, I've done what I suggested in the previous part and worked out the mass of the hydroxide group and multiplied it by 2. We now rearrange our equation. So number of moles is equal to the total mass of moles divided by the mass of 1 mole. So 5.8 divided by 58 gives us 0.1 moles present. The final example question of this type is, how many moles of iodine molecules are present in 25.4 grams of iodine? Note with this question, it asks how many moles of iodine molecules are present rather than iodine atoms. Stage 1, we need to write down our key equation and identify what we know and what we don't know. Stage 2, we can easily work out the mass of 1 mole of iodine molecules. So the mass of 1 mole of iodine molecules is 254 grams. We can use our equation, rearrange it to the following. Number of moles is equal to the total mass of moles divided by the mass of 1 mole. So we find we have 0.1 moles present. And hopefully it's all going really well, so here is a joke. Why do iodine molecules see so well in the dark? And the reason is because they have 2 eyes. This also hopefully reminds you whenever you write down iodine down as an element, it consists of I2. The final question type is to calculate the mass of 1 mole of a compound given a mass and how many moles which are present. This sort of question seems to come up very, very rarely, but for completion it's included, and also it helps ensure your familiarity with rearranging the equation. Stage 1. We write down our equation. In this particular case, we know the number of moles present, and we also know the total mass of moles present. So we rearrange the equation. The mass of 1 mole will be equal to the total mass of moles divided by the number of moles present. So this means we have a mole which has a mass of 100 grams per mole. Sometimes there may be an extension to this sort of question, which maybe makes it a little bit more interesting. So after having calculated the mass of 1 mole is 100 grams, it states that it's a group 2 metal carbonate. So this would have a general formula like MCO3, so it could be MgCO3, CaCO3. And the question will ask, what group 2 metal does it contain? Some example metals for group 2 are given: strontium, calcium, magnesium, and beryllium. 100 grams is made up of the mass of whatever the metal is, plus the mass of 1 mole of carbon atoms, 12 grams, and also the mass of 3 moles of oxygen atoms. So for example, beryllium carbonate, the total mass will be equal to 9 grams from the beryllium plus 12 grams from the carbon and 16 times 3 grams from the oxygen. We've got a mass of 100 grams, so clearly we can see it's not actually beryllium. Here is a general equation for the mass of that compound which has a mass of 100 grams. So it would be equal to the mass of 1 mole of metal plus 1 mole of the carbon atoms plus 3 times the mass of a mole of oxygen atoms. So if we fill in the details we know, the mass of the carbon and the mass of the oxygen, we have the following equation, which is giving us a clue that the mass of 1 mole of metal plus 60 grams gives us 100 grams, so the mass of 1 mole of metal must be 40 grams. Looking here, which element from group 2 has a mass of 40 grams per mole, and we can see it must be calcium. Here is another question in that same style. What is the mass of 1 mole of a compound given 42 grams contains 0.5 moles of it? Stage 1, we obviously need to write down our key equation, identify what we know and what we don't know. Rearrange the equation, so we can say the mass of 1 mole is equal to the total mass of moles divided by the number of moles, and we find we have 1 mole having a mass of 84 grams per mole. This 84 grams is going to consist of whatever the metal is, 1 mole of those atoms plus 1 mole of carbon atoms plus 3 moles of oxygen atoms. So with a little bit of calculation, we can find the mass of 1 mole of metal plus 60 grams gives us 84 grams, so the metal must have a mass of 24 grams per mole. And from the relative atomic masses shown here, we can see the element which has a mass of 24 grams per mole of atoms is magnesium.